Intergraph Corporation shows you how a GIS can be used to find the best place to site a new manufacturing facility. Here's the problem. The plant must be close to year-round streams, within 1.5 miles of a major four-lane road, be on flat ground, and must have access to sewage facilities. Let's see how the GIS can be used.
Now, there are several ways we could approach this problem, as I said before. The first thing we're going to do, though, is simply analyze the very basics of this industrial site location criteria, and we'll do that in a pure graphics environment. We won't create a topological data structure. We won't do anything sophisticated. We'll simply use the human mind to make some basic decisions about the study area. So what we'll do, as soon as that grid model finishes painting, and we can take that grid model also. Right now, each grid cell in that grid array has an assigned slope, average slope value. We can take that and generate from it a polygon, in essence, of all the grid cells combined into one polygon that are of a single slope value. So rather than deal with a large array of numbers with each grid cell or each XY location having a slope value, we can simply deal with one large polygon of this is the area of 18% slope, this is the area of 0.2% slope. All right, let's go back. This is the study area, the county in essence, or the study area designated by your particular customer. The first thing he asked for was to be within 1.5 miles of a major four-lane road. All right, that's a very simple problem. We simply create, using our spatial analyst software, a zone, graphic zone around the major four-lane highways, this one up here, within the study area. All right, that's one simple criteria for a site. The other was he wanted to be close to a stream that flowed water 12 months out of the year. By selecting those streams or the proper characteristics and then generating a zone around those streams, we can see the intersection visually of the zone that's 1/8 of a mile from the stream and 1.5 miles from major four-lane roads. Visual analysis only, nothing sophisticated going on. All right, the next criteria was he wanted to be within corporate limits that would guarantee him water and sewer treatment over a specified period of time that he would negotiate with that municipality. But he wanted to be within a municipality to guarantee that. All right, all this analysis to this point is pure IGDS, we call it. It's just graphics. But you can make some very valid assumptions about this study area just with simple graphic overlays. First is, I want to do detailed analysis in this area because it's within the distance criteria, is within a few streams that I need, and is also within the corporate boundaries of this particular municipality. All right, at this point is where we use selective topology, the concept I mentioned at the very beginning of the demo. What we're going to do is take the slope map with its various categories of slope. We're going to take the soil map and all the associated attributes of those soils, and we're going to take the 100-year, 500-year, and above 500-year flood hazard areas, and we're going to combine those three graphics files that have database linkages, but basically graphics files, into one topologically constructed file. All right, now Intergraph stores, like this graphic you're seeing on the screen here, is stored in what's called a design file. It's very efficient in terms of interactive graphics, but it may not be the most efficient way to deal with topology, because once you structure with topology, you're no longer dealing with graphics, you're dealing with the mathematical relationships and the spatial relationships of each particular line segment or arc between two nodes. So we chose not to create a traditional design file in that topo file. We, in essence, store that design file as coordinate data, and we'll review it and we'll look at results of it, but we don't treat it as just graphics anymore. But, as I mentioned earlier, Intergraph has a reference file capability. Over in that window, you see graphic depictions of what is in that topologically constructed file. The gold lines you're seeing there are the soils data. The green lines are the polygonized grid data from the slope map that I talked about earlier, and the blue lines are the 100-year, 500-year, and above 500-year floodplains. We also called up the transportation overlay and the municipal boundary as just a reference to give you an idea of what's going on.
Many of you may be thinking about buying your first